Okay, so let's start. Ostwald dilution law. We are going to study Ostwald dilution law. What is Ostwald dilution law? Okay, we are going to study Ostwald dilution law, or I can say that we are going to study Ostwald dilution law, or I can say that we are going to study how we can make a weak electrolyte behave like a strong electrolyte. See, as I told you earlier, that electrolytes are of two types. Either they are a strong electrolyte or they are weak electrolytes. In our case, weak electrolytes are not good for us because weak electrolytes do not dissociate completely, so their conduction is not proper. Like if we have taken 100 molecules, then only one molecule dissociate, two molecules dissociate, so that's not good for our electrochemistry, because we want that the whole molecule dissociation takes place. So the question is, like, on the basis of nature of compound, some electrolytes are weak, but we don't want them weak. We want that those weak electrolytes also behave like a strong electrolyte. So I am going to teach you, I am going to discuss with you that how a weak electrolyte will behave like a strong electrolyte. Okay, so discuss that. I'm going to show a very simple concept of equilibrium. That is, suppose I have electrolyte AB, okay, and AB electrolyte is not strong. I consider that AB electrolyte is not strong, so it is a electrolyte, so it dissociates into A plus and B minus. Okay, but it's not a strong electrolyte. It means it's a weak electrolyte. And if it's a weak electrolyte, so for weak electrolyte, its alpha is not equal to 1, means alpha is very less than 1. Okay, suppose when reaction start, that is T equal to 0, we have taken its C concentration. Now slowly reaction proceeds in forward direction, and a time will come when equilibrium attain. So at T is equal to T equilibrium, it's C minus alpha mole dissociated and C alpha mole form of A and B. Why we are doing this? Because it's a weak electrolyte. That is, it's not possible that how much we have taken the whole molecule dissociate completely, there must be some molecules remaining in the solution, since it is a weak electrolyte. So now the reaction is equilibrium. So if reaction is at equilibrium, we can write its equilibrium constant. So what its constant will be? Its equilibrium constant will be K is equal to concentration of product, that is A plus, into concentration of reactant, that is B minus, upon concentration of AB. Okay, concentration of product, that is A plus and B minus, upon concentration of AB. Now at equilibrium, its concentration is C alpha into C alpha upon C minus C alpha. Okay, so it will become C square alpha square upon C, we have taken common, and 1 minus alpha. So C will cut with 1 C, then K will become C alpha square upon 1 minus alpha. As I told you earlier that alpha is very less than 1, so K will become C alpha square. Since alpha less than 1, so 1 minus alpha is approximately equal to 1, because it's a very small value, and compared to 1, it's a very small value. So 1 minus very small value is approximately 1. So I can write K is equal to C alpha square. Now alpha is equal to K by C under root. Yes or no? See, this is a weak electrolyte. Okay, this is a weak electrolyte, and we have found out its alpha, and we know that for weak electrolyte alpha is very less than 1. So what's our objective? Our objective is we want to increase value of alpha. Okay, our objective is we want to increase value of alpha. So how alpha can be increased? From mathematics we know if a number K is A upon B, so K can be increased if A can be increased and B can be decreased. Means by increasing numerator and by decreasing denominator, we can increase value of K. In this case, alpha can be increased if we increase K. C means concentration, which is basically N by V. So alpha can be increased. Our objective is to increase value of alpha. Alpha can be increased if K increase, but since we know that for any particular reaction K is constant at a particular temperature, so K is constant, we cannot increase K. Now the second case is N, that is number of moles. We decrease it. So how much we can decrease it? Decreasing number of moles does not have any physical significance. Why? Because if we decrease number of moles, it means what? We haven't put electrolyte and we are saying that alpha is 1. This doesn't mean any physical significance. It's something like we don't put any electrolyte and say it's a strong electrolyte. That's wrong. So the only case left with us is we can increase alpha only by increasing value of V. So how much we increase? We can increase V and we can increase V and so on. And when V, that is volume, is so much, this is known as infinite dilution. What? Infinite dilution. So alpha can be increased if V increase, that is dilution increase. So we can say that any weak electrolyte will behave like, see, it is to be noted down, I am saying behave, I am not saying it become. A weak electrolyte will behave like a strong electrolyte at infinite dilution. Okay, so this is known as Ostwald dilution law.